this question here, find the relationship between m and the rate of change of m. You might be able to spot it straight away. It's an exponential, and so actually the rate of change is proportional to m. That's the definition of an exponential. But it's probably a good idea to just to find what the rate of change is. Now we know that d by dx of e to the kx is k e to the kx. If k is 1, we've got the special case that if we differentiate e to the x, we just get e to the x. If there's a constant up here, then you have to multiply by that. So if we do that in this case, we're going to multiply by the 2, and we're going to get 150 e to the 2t. That's fine. You could write this as 300, but actually the thing we want to do here is say that it's equal to 2m. So still this model applies. They are proportional. So what we're saying is as one doubles, the other doubles. That's what proportional means. And as m equals 0, when n equals 0, dm by dt equals 0. You do need to say that that it's equal to 2m. It is 2 marks, so you can't just say that they are proportional. Part B, what's the significance of the integer 150 in the model? So let's just read the question again. It's the members of a social networking site. And so this 150 is when t is 0, this e to the 2t just becomes 1. And so when t is 0, m is 150. So it's a starting value. And you might say the starting value, if you give it a bit more context, you might say it's the original number of members. Or initial number of members. All good. Find the week in which the model predicts that the number of members first exceeds 60,000. So for this, we need to solve that 150 e to the 2t is greater than 60,000. Here we've got like an exponential inequality. You can do this by taking logs. First thing I would do would be to divide by that 150 before I take logs. So e to the 2t is going to be greater than 400. And now do ln of e to the 2t is greater than ln 400. The 2t comes down, and ln of e is just 1, so I basically get that t is greater than ln 400 over 2. Hence, t is greater than 2.9957. Now, does that mean it's right at the end of week 2? It's not really that clear here that t is a time in weeks, but in the mark scheme, actually, it assumes that t is a discrete amount, but I don't really like that because it doesn't really say that it has to be a whole number of weeks. So, but I'm just going to say that in the mark scheme, it then said 3 weeks is the final answer. I personally think if you say at the end, right at the end of the second week, then that would be okay. But the answer is looking for 3 weeks. It wants the weeks to be a discrete amount. For part D, the social networking site only expects to attract 60,000 members. How can we refine the model? This is only 1 mark. At the moment, we've got an exponential model that's going to keep increasing forever. So basically, we need to make the function constant. When it reaches 60,000. A slightly more like technical, and I actually think this is a really nice answer. The mark scheme didn't talk about it. Would be to actually define what this would look like. So it would be that m is 150 e to the 2t between 0 and this 2.9957. 60,000 if t is greater than or equal to 2.9957. That's it. Okay, that's his question. I'm not really happy with part C, the fact that on the mark scheme it's given us 3 weeks, because I don't really see the purpose of a model that only really predicts, like, you've got your initial values which you know, and you know that you can expect 60,000 people after 3 weeks essentially, I suppose. But then it's only going to give you information on after week 1 or week 2 as well, so it's giving you very limited information. I think it would be useful to know how many after 2.5 weeks, after after 9 days, for example. But that's just my opinion on this model. That's the answer to the question in any case.